In the previous lesson, you programmed your robot to turn while its gyro sensor was less than 900, or 90 degrees, and then stop. But when you ran the program, the robot moved more than 90 degrees. Why? The primary cause is momentum. Even after the motors are told to stop, it takes a little while for the robot to actually stop. We can compensate for the momentum with two simple adjustments. Adjustment number 1. Lower the speed of the motor commands to 35 and negative 35. With the motors moving more slowly, there will be less momentum and less drift. Adjustment number 2. Account for some drift in the desired heading. Since the robot will still experience some drift, we can change the while loop to use a value a little less than our desired heading. Change the 900 to 870, or 87 degrees. The while loop will repeat until the value of the gyro sensor reaches 870, but the robot will actually stop closer to 900. Test the new program with your robot. The robot's turn is much closer to 90 degrees. Great! Now, one common misconception when working with the gyro sensor is that when it's time to add another 90-degree left turn behavior, we could use these exact lines of code again. In reality, though, since we are only resetting the gyro sensor at the beginning of the program, its value is already greater than 870. The while loop would check the condition, which would be false, and the robot wouldn't perform the turn. Instead, any subsequent turn should take the current gyro sensor reading into consideration. For instance, if we wanted to perform another 90-degree left turn, we would change the condition to repeat while the value of the gyro sensor is less than 180 degrees, minus our adjustment value, or 1770. By only resetting the value of the gyro sensor at the beginning of the program, all subsequent turns are relative to the robot's initial heading. Even though the gyro sensor doesn't eliminate momentum, it does greatly reduce the issue of accumulated air. This is extremely valuable in programs where your robot needs to accurately and reliably complete many subsequent movements, like in the Grand Challenge.